Okay, so welcome to our presentation, everyone. My name is Chris.
Oh, and hi, I forgot this. Okay, the second time. My name is Dan.
Don forgets her name sometimes, but we're good with that. So our presentation is on BucketSort. So without any further ado, let's get right into the basics on how BucketSort works. So how BucketSort works on basic level is you have some buckets and you have some data values. The data values are easiest to work with are numbers generally, like floats or integers. And so generally what you're going to see with my beautiful and enviable PowerPoint animations is that it takes the values, and usually it takes the values from left to right. But for this example, it just started with 22. But so you can see 22 goes into the 2 category, 11 goes into the 1 bucket, 34 takes a roundabout route to the 3 bucket, and then 25 goes into the 2 bucket. And so now we're going to see how that is undone with more animations. So you can see then 11 is spit back out first in the list in the array, and then 22 is next, and then 25 follows that, and we ended off with 34 to complete that sorted list based on the method of BucketSort. Except now we're going to look at some more complicated code and a little bit more in depth about how it works. So here's Don.
Hi. So this is the pseudocode of the BucketSort. Like after that fun animation, you have to look at this code. So first of all, we have to create an array of sequences and initiate it with empty. And usually linked list would be used. The length should be in the range from 0 to n minus 1, with n is the length of the initial array. From there, we just have to go through the initial array, use each value to figure out a key, which usually is just a function of like mod or like multiply or an kind of like integer cast, usually pretty simple. And then you would add that value to the bucket at that key. And after all that, we would sort each bucket with another sorting algorithm. And then we finally just have to iterate through each bucket and put the sorted value back to the array. Sorry, my bad. But moving on. So from what we can see, BucketSort is not in place because we would have to make another array of bucket for it to work. Okay, next slide. And here just a video of the algorithm, so just to help you to better like visualize how it works. As you can see, that's how it worked, and I think they use the insertion sort here to sort the bucket. So it kind of depends on the algorithm they use to sort the bucket, but generally the bucket sort is stable because each values is added to the bucket in order and then get on concatenated in order back to the sorted list. That is my part.
Okay, so now we're going to go over runtime. So the worst case performance for BucketSort is O of n squared, but there's a little bit more to it. This can happen, especially when, okay, sorry, that wasn't loading. So it can become O of n times k, and k represents the number of buckets. So that's kind of what it is. And when k is small, or when one bucket doesn't have a lot of values, then that will transition to the best case or average scenarios, which we'll look at in a little bit. But when k is large, or there's a lot of values in one singular bucket, then that k can about equal n, and O of n times k can turn into O of n times n, or O of n squared, which is the worst case performance. Now the average performance is also basically the best case performance, which is complicated, right? Not when you can just cancel out. So you have O of n plus n squared over k plus k, which then with k about equal to n, which is best case performance. There's not a lot of not too many buckets in this case. So then you can see how it cancels out to O of n plus n plus n, which is O of 3n. But since there's no higher order, this is basically just O of n. So that's the runtime. And now we're just going to last parts of bucket sort. So kind of how I mentioned earlier, it works best with numeric data. String data is still possible, but it's a lot more complicated code in order to make that happen. And bucket sort can also be used to develop more complex sorting algorithms, and radix sort is an example of this. So it can definitely be more useful than just what meets the eye. So there you go. There's our presentation on bucket sort. We hope you enjoyed our presentation. I'm sorry if my face was laggy. I know all of you would love to look at my face, so definitely apologize for that. And it's pretty bright behind me as well, so do apologize for that. But thank you for watching this, and goodbye.
Thank you. Bye.